on the 4th of December, and ourselves, the next one is on the 27th of November, which is Dr. Dave McGarvey on volcano ice interactions in Iceland and Chile. But this is a remote talk because Dave lives in Edinburgh. So we won't presumably be in the building here at all for the next one. And then the further one is on the 11th of December, the Hertfordshire Lagerstätte soft body virtual fossils from a Silurian volcanic ash by Professor David Civita of Leicester. There were others, but I can't remember them, and they didn't come out on my cheat sheet when I tried to record them. So tonight we're to welcome Dr. Frank Ince. He's an Essex guy whose other hobbies were football and athletics. In fact, he was a goalkeeper and indulged in throwing the discus. He went on to Birmingham University, obtaining degrees in chemistry, to become a research organic chemist at the pharmaceutical division at Loughborough of, initially I take it Phison's, and then AstraZeneca, as they morphed. And it must surely have been his other interests of rock climbing and mountaineering that got the inorganic chemistry in him to come to the fore, because getting hands-on to the rocks is irresistible, I suppose. So Frank has been a member of the Russell Society for a long time, having held positions of president, secretary, journal manager, and central branch organizer. So please welcome Dr. Frank Ince, who's going to talk to us tonight on Earl Ferrers' lead mine, Dimminsdale, its history, geology, and mineralogy.
Come on. Right, we can't share the screen. Ah, there we go. Okay. Okay.
Evening all. Right, so been interested in Earl Ferrers lead mine for quite some time. And, might be fortunate to have Neil here because he knows a bit more about some of what I'm going to talk about than I do. So, you know Neil Hubbard. Right, let's go on with it. All things work differently, don't they? Oh, yeah, I'll do. Okay, I'll use that now. Earl Ferrers lead mine. There are two lead mines in Leicestershire. Well, one is really just a trial, which you may already know about. I've spoken about this in the past to the members evening. But the one we're talking about tonight is Earl Ferrers lead mine in Dimminsdale, which, as you can see from a larger scale map, is very close to the border between Derbyshire and Leicestershire. That has actually caused some confusion, as we will see in a bit, But here, between Staunton Harold and Corbett Abbey, Ticknall over there, the one confusion is the name. This is the mine name that's been used on and off over the years. They mainly have various forms of Ferrers in them, but the locations is a different matter. This is actually quite a cause for concern historically. The address, if you like, is Dimminsdale, Staunton Harold, Leicestershire. It's been known as Staunton, Ashby de la Zouch, even just Leicestershire. And some of them, unfortunately, have been designated as originating from Ticknall Hall or Ticknall, which is obviously in Derbyshire. And you'll see these variants of them sort of scattered all across the literature. So we start with the history. It's been known for quite some time that there were deposits of coal, limestone and ironstone in the Staunton Harold area. And lime quarries, we'll deal with those first. This is a larger scale map. So again, border running through Dimminsdale. The mines and the quarries are at the confluence of the Calc Brook, which obviously is on the Harpur-Crewe side, and the Staunton Brook, which is on the Ferrers side. And there are three main quarries, which are the residue in the main, the lime workings. And if you stand more or less where this FB is, oh, no, going back to a different map. Pardon? Oh, right. Yeah. Yeah, right. I shall use the arrows now. There are the remains of lime pits, which are actually in the Harpur-Crewe area. It's a dotted line across here. And the footbridge that was mentioned on the map is this one. So we're on the Derbyshire side of the Calc Brook, with Leicestershire behind the trees over there. In fact, one or two of the ones on the path that goes up to the car park are actually still quite deep. These are rather shallow. There's also coal in the area. So it's starting to look a little bit like an industrial revolution site, and that would in fact be the case. All of this sort of happening in the 1700s. Staunton Colliery. But this is actually part of a much larger, industrial landscape. So Dimminsdale Leadwork Lime Works and Staunton Harold are where we're going to spend most of our time. But the cork lime works at Ticknall were actually much bigger than these and run by the Harpur-Crewe family. But there are also a whole host of exposures and small shafts leading down to the coal measures, which go up and down here. As we'll see, the geology later is quite complex. It's known that there was lead mining probably 1775 or before, because we'll see in a moment Prior's map, which was 1779, and there are quotes in the literature saying that there was lead being mined in the Dimminsdale for at least 4 years before Prior's map. This is Prior's map, at least the area of it that's related to the bit that we're interested in. So you've got Staunton Harold here and Cork there. And from that point of view, I'll blow it up actually, I think you can carry on. Yeah. So there's a little bit more. As you can see, it shows the border, which more or less follows the Calc Brook and the Staunton Brook that comes from Staunton Harold, and the lime lead works are over here, which is actually not quite where they are. We'll come back to that later. Moving through history a little bit, interestingly enough, in the 1780s, there were well-known specimens from Staunton Harold being sold in Paris by Jacob Forster. And this is detail, there's quite a lot of detail in this about Mick Cooper's book, Robbing the Sparry Garnature, which if you're interested in mineral dealers for the 1750s to 1950s, it's a very interesting book. 1790, the Rashley collection in Cornwall. Rashley was probably one of the preeminent collectors and buyers of minerals in that period. He had a lot of money from the Cornish tin and copper mine, so it's not too surprising that he built up specimens from elsewhere. We can see these specimens are actually being sent all over Europe. And indeed, we'll find later that there are specimens in quite a number of foreign museums. There are some commentaries about life and the university in Leicestershire, Throsby, Nichols and Fairy. These are plus or minus 1800. And they all mention lead veins on the Ferrers estate. So what about the lead mines themselves? Well, we've seen this map before, but the lead mines, does this have a pointer on the other one? Does that not actually have a pointer? I think the battery's run out of this. I should have something else. Yeah, I'll wiggle around with the mouse and rearrange the furniture. So you can see here it said lead, lime and lead works. Well, it's really related to this area here. And associated with those lead works are a couple of other features which we'll deal with here. There's something called the Springwood Cupola, which, as it suggests, is in Springwood. And this is a building that's been called the office in this currently. And this seems to be part of the cupola.
I thought it was on the television.
Yes, it's supposed to be.
Yeah.
Yeah. Don't know what.
Well,
This is a problem because I needed zoom and
Not me, got that.
I don't know what.
Right. Might be helpful if you switch your microphone on. Yeah. Up the hill from there, this was discovered by Bob King, as far as I'm aware. It's one of his photographs. There is a flue that goes up behind that building up the hill towards the east, and he's conveniently put his walking stick on there to show the signs of where the flue goes. There's also slag. You can see where the pointer is now. Bob has actually written on this map slag, and sure enough, during the recent drought, Neil took advantage of walking down towards the water's edge on what is now Staunton Harold Reservoir, and sure enough, there is slag there. Well, material that looks very like slag from other places, so we assume it is that. The next most interesting thing also about the turn of the 1800s. No, please. Thank you. There is an oil painting thought to be of the Dimminsdale Quarry and Mine, and it's this one. It's here in Leicester, it's in New Walk Museum, because it was bought by the county from the Consolidated Goldfield, where it used to be in their boardroom. And you can see that it's sold at Sotheby's in 1990. And as you can read from the caption down below, that is limestone quarries and lead workings at Dimminsdale on the Ferrers Staunton Harold estate. So makes it look quite impressive, I think. Probably we'll use this later. This little fellow, I'm assuming, is 5'6" high. And that, when you do the multiplication, means the face is between 40 and 50 feet high. And you'll notice that it's actually worked by pillar and stall mechanism or method. And over here, with what appear to be lime kilns. So there are a number of interesting features on this painting, and we'll come back to some of them later. Sowerby, who wrote British Mineralogy in his volume 2, he mentioned the occurrence of chalcopyrite, calcite, sphalerite, etc. at Staunton Harold. And he also includes in plate 156 is the specimen from Staunton Harold. And this, looking at Staunton Harold specimens today, there is no doubt that this is very similar to the material that we actually have found in various places on the SSSI. And the interesting thing was that it was sent by Earl Ferrers, in Leicestershire, to Miss Codrington. Now, if any of you have got a Codrington in your family tree, it'd be very interesting to know about it. Chance is pretty remote, but you never know, because as we'll see later, this specimen has actually been lost. We'll come back to this because it's got some interesting features which are mineralogical in nature. Jukes, who wrote quite the Geology of Charnwood Forest, which was an appendix in Potter of that era, also mentions bunches of galena extracted from a pipework. So it looks as if it's a series of pipes and with galena actually embedded in them. In the 1840s and 50s, there was quite a lot of legal action over a collapse of the limestone quarry and mine. When it gets a bit legal if you read through stuff, but from our perspective, it's quite interesting because they do have maps and plans of what happened. So I appreciate this is not the best that you can read, it's been useful to have had. But on the left-hand side, you've got a plan. On the right-hand side, you've got a section. And the plan, as you will see, wander around for a bit. Here, you've got an open area, which may well be the void that you saw in the photograph, in the painting that's in the county collections. And on the right-hand side, it's interesting that all the various beds that they were going through are labelled in terms of A, what they were called, and B, how big they were. So if we look at the section first, what they were interested in at this stage was the limestone measures. And you can see there are a whole variety. One in question which caused the issues was this one, which is called marble, but that's obviously not correct from a geological point of view. But it appears that this was actually being mined by the guy Matthews, who was a quarry manager, and Ferrers didn't like that because it actually caused a collapse, taking that as a fairly solid band, and that was actually the roof of the pillar and store works. If we go over to the plan now, then you can see the original line of the quarry, which was highlighted, and this was what happened in 1853. All of that lot fell in, and underneath you can see the hatching that's in with little dots, more or less the bit where the line that I've drawn showing the sign of the face, the site of the face, was all material that had fallen down inside the mine, inside the quarry. On top of that, which we haven't looked at before, were the lead measures. So this was also an interesting point of view that these actually do mention the lead measures. As far as I'm aware, this is the only section that's available to us that says where the lead measures were with respect to the limestone. Although perhaps one might have predicted that they were later than the limestone. The interesting thing again is if you total up the distance from the surface to the bottom, then you see that it's 50 feet, more or less. And our little man and his face is also about 50 feet. So it does seem to tie in that the depth of the workings from the top to the bottom were 50 feet or so. One thing that's not quite so easy to see on the plan is that at the other end, highlighted here in red circles, there are actually lead mines which appear to be very similar to the sort of plan that you would see in a mine that was actually following pipes and veins. So it, again, corroborates the fact that there were lead mines here. Greg and Letson, who wrote their manual of mineralogy in the middle of the 1800s, galena in fine crystals from Ticknall Hall. So, which obviously is not correct, but it's because no fine crystals have been found on the Harpur-Crewe estates. Moving on a bit now, there are alternative versions of the plan of the mines and the quarries, and this one was in Bob King's archives. I can't recall now where it actually came from, but we'll, if we turn it to face north, then you can see that the quarry is occupying a north-facing void with the limestone kilns on the north side, and in between there is quite a large void. At this stage, that wasn't flooded. We'll see what happens later. If you compare that with a modern map, then obviously everything that's on the Harpur-Crewe side is missing on the left-hand map, but on the right-hand one, we've obviously got the two quarries. As far as I'm aware, nobody has really investigated those two quarries for their mineralogical content. They're not easy to get at, from one perspective, and they're obviously on the National Trust Cork Abbey site. The Laundry Pool, which is now where the quarry was actually quite a large body of water, as we'll see in a moment or two. There are one or two interesting consequences of having the buildings that are on the left-hand map. This one here is the site of what is the laundry, and that presumably gave its name to the Laundry Pool, because this seems to have been a place where people in Staunton Harold sent their washing. Otherwise, I find it difficult to believe why it would call the Laundry Pool. And if you look here on the bottom of the map, you can see that it corresponds to an area that's garden on the 1850 map, 59 map. And if you look at it now, it's a snowdrop meadow. Some of these have been planted, but presumably there were snowdrops in there. Rudler, who wrote a book about the Ludlam collection, which is now in the Natural History Museum, also has specimens, more details of specimens from Staunton Harold, showing calcite, galena, pyrite, sphalerite, and bitumen. So we're starting to build up at least a mineralogical picture of what's actually been found under the ground. We've come forward a few years now until just in pre-Second World War, there was an effort to actually sort of find all sorts of places in the UK that would help with the war effort. And one of the attempts here was by Ferrers to reopen the mines. And at this time, they were visited by Arthur Russell. Two shafts were constructed by Ferrers in this period. One was to see whether it was still possible to mine lead ore, and the second one was the creation of a government store, in this case for 250,000 tons of TNT, which they wanted to store, presumably somewhere safely and away from bombing by other people. But the workings were too unstable rather. So our question was, where are the shafts? Well, fortunately, Bob King, who was around at the time, and he drew a sketch map of the area. So I recommend this to you from a collecting point of view. Do a sketch map occasionally, because this has actually been quite useful as far as I'm concerned. We can do the same as we did before, turn it north-south, so the north line is going up now. And then again, compare it with a modern map. You can see the Staunton Brook in both of them going more or less vertically up. It now, on the map, now runs into what is the flooded area related to Staunton Harold Reservoir, which is off the top. And if you start looking around, oops, not that one. Go away. Oops. You find there are two shafts. Well, there are two areas where these shafts would have been. One is down by the footbridge, which is right at the bottom of the left-hand map, and the other one is on the edge of a refuse from the mines, quarries, that's at the top left-hand side, just on the west side of the Staunton Brook. We will come back to those later. This is what it looked like in 1939, 42. This was actually, I think it was the northerly shaft. This was where it was being pumped out in an effort to actually see and go underground, which was done, but I don't have any pictures other than this one related to the draining of the mines. In fact, if you won't be able to read the little label on the side of the pump, but it is actually, this is a blind alley, well, not a blind alley, but it's an alley that I went down just for the hell of it. And so, in fact, the name John Tom, go back a little bit to the Pages Weekly, but they were a well-known artesian well and water producing company that were in Manchester. So, having found out where the shafts were, these are some comments that came either from Bob King or Arthur Russell. The first one was coliform masses of marcasite and probably pyrite were between the limestone and shale in the roof of the old workings, which again would fit in with the way in which the section of the mine was shown on the earlier map. And that was from a letter to Bob King from Arthur Russell while they were talking about these things, and some specimens were recovered by Russell and they're now in the Natural History Museum. And Ferrers gave Bob a specimen in 1948, and we'll see that later. But it was collected in this period in 1939. So looking at it from a modern perspective, the yellow highlights are the SSSI and Nature Reserve related to Dimminsdale. So it covers most of the area that we're interested in, and obviously it disappears up the side of Staunton Harold Reservoir. And the county boundary follows the course of the river that was, but now goes down the middle of Staunton Harold Reservoir. So looking at the map again, it's the layout of the lead mines. You can see there are maps, slightly bigger scale. You can see there are all sorts of little humps and hollows actually present in the fields which are south of this of the laundry pool, and they do show up reasonably well on Google Earth view. Again, the the Laundry Pool, Staunton Brook, Calc Brook over here. And there are all sorts of little humps and hollows and ridges, which, as we will see, can be investigated further. Now, if you stand on the other side of the Staunton Brook and look across, you can actually, particularly when the sun's a bit low on the horizon, you can actually see all the humps and hollows in this field. It's not much to see on the other side or off the right-hand side of this map, of this image, because it's the tree-covered Dimminsdale, basically. Over the last 5 or 10 years, Neil and I have made it our business to find out as much as we can about the surface of these of the mines, and there were in 2 different groups here. So deal with the shafts with the crosses in first, and then we'll deal with the open cuts later. So if we look at the shafts, which I've arbitrarily numbered 1 and 2, they're actually on the top of the hill, as you look on the right-hand side of the previous photograph. Looking from the Dimminsdale side, south more or less, you can see there's a conical depression just in the foreground that looks suspiciously like the remains of a shaft. Whether it is another matter, but it is possible. In the background, just down the hill from this copse of trees, you can see shaft number 2. You can see the palisade, if you like, and the network of barbed wire around it. This is a more interesting chart from our point of view, because in the 1970s, the Russell Society got permission from the Ferrers family and the Water Board to actually dig this shaft out. In the shaft, we've got Bob King, along with John Jones, who's maybe known to some of you, John Shepherd, seem to be the only ones who are doing any work. In fact, there's a rather young Neil Hubbard there. This is an interesting dog as well. This is Piper. That used to go everywhere with Bob, and I'm sure it was a bit of a nuisance to all concerned sometimes, but it was a very friendly dog. It was actually a well-made shaft. These are only the top 6 or 10 feet. It's quite well lined and boded well. It got fairly deep enough to actually want some mechanical assistance for getting the muck out, which was done with the petrol motor driven winch and the plastic container there. The shaft was dug, as you can see at the bottom, it was dug to 76 feet. And from what had been done in terms of looking at the sections of the rocks around here, it was probably 5 or 10 feet from the workings. But water started to come in from just before 70 feet. And in the end, it was just too messy and probably hazardous to actually be down there digging it out. There was another effort to actually see if these mines could be looked at earlier or a bit later on in the 1980s. This is a site committee meeting, again, with Bob King, who actually wanted to clear the shaft and actually pump the water out of the mines. One thing that they had realized by now was that the mines and the laundry pool were obviously connected. So when you look at all the work that had been done on the map earlier, you can actually work out roughly the volume of the pillar and stall workings, which are presumably still there. And also you can actually probe the depth of the laundry pool. And if you do that, you end up with near 3.7 million gallons as an approximation of the amount of water that will have to come out in order to drain the mines. And needless to say, the water board weren't too keen on that amount of water going into the Staunton Harold Reservoir. So it didn't work. This is what it looks like now, more or less. Still got its fence around it, still got a pile of brushwood logs on the top that is effectively sealed. There are a number of shafts. You can see here the path, which is the laundry road, which connected the laundry to Staunton Harold Hall, curiously enough. And there are 4 shafts shown on this map. They were shown on Bob's map that was from his thesis. And this was a picture that he took of them in 1958. So the first one on the bottom left is shafts 3. 4 is the one with cows. 5 is the one on the top right-hand corner, and 6 is the one in getting towards the background. So, and shaft 4 was actually the first shaft they dug here. It obviously produced a considerable amount of rubbish. I think it's been used by the farmer to dump anything he didn't, or farmers to dump anything they didn't really want. But that didn't get as far as the one on the top of the hill, which is shown in the background here. And it got so muddy that it was just closed down. It would not be possible. And it's not too surprising because it's only a few feet above the level of the Staunton Brook. This is what it looks like today. It's gradually becoming grassed over. It's a little bit, everything here is a little bit more in the distance, but the shafts are still there. But there are still lots of other humps and hollows that haven't been investigated very well. Put on here shaft 7 and 8. These are possible entries to the mine. They would both be adits rather than shafts, I think. The only one that I've got a photograph of is the 8, nearest the wooded part. And there's a depression here with reeds and water-loving plants growing in it, and it does look like what you would find from a caved-in adit going into the hill on the right-hand side. Shafts 9 and 10, as I say, they were on Bob's map, although they're in slightly different positions. Neil and I spent a happy couple of hours fighting our way through the undergrowth, particularly to get to number 9, which appeared to be a fairly nice brick-lined top to the shaft, but it was full up with water, needless to say, because it's more or less at the level of the river or the stream. And the one on the other side was similarly, but it's at the bottom of quite a steep slope. So it's which was the old tip. Unfortunately, I've not got a photograph of either of those. That was a mistake on my part, not to take a camera. Shaft 11, an interesting shaft, this one. It's obviously on the edge of the laundry pool. And it looks like this now. That's a laundry pool in the background and another quite well-defined conical depression, which again, based on experience from other parts of the country, would be an indication that there was a shaft there. And that takes us back to our picture, because on the top of the on the land surface at the top of the quarry, there is in fact an engine house, which looks as if it's either a winding engine or a pumping engine. And from that point of view, that there is a possibility that that could be a representation of shaft 11, but I'd be surprised in one sense, because quite a lot of this has subsequently fallen in. So it's a bit close to the edge of the old quarry versus the one that appeared in the previous 1850s legal cases. There's a semblance of a shaft, possibly. This one would be in Derbyshire, because it's on the other side of the Colt Brook. But it was a really sort of muddy hollow that looked as if it was a water-filled conical section. And there's one that I've walked by numerous times, but it was only the year before last that somebody pointed out that there was actually a shaft there, but it's just over the path from where the laundry building would have been, so it might actually be a well rather than a shaft. But looking at it, it's definitely a hole going down into the ground. It's not in a very easy position to investigate, so I have no idea what goes on below the level of the camera shot. Presumably run into water fairly quickly. And then there are open cuts. I've detailed 5 of them here. 4 are on the same area as we've got with the lead mines, and 1 is on the hillside on the other side of the stream. Some of these are quite sort of extensive areas of reedy humps and hollows, and some of them may well have shafts in as well, but without digging around a bit, it's difficult to say. So geology, we've mentioned it once or twice. The area is actually mentioned on William Smith's map. The little blue blobs, or dark blue blobs, are actually limestone. And you can see ones at Breeden Hill, Worthington, which is Cloud Hill Quarry, Barrow Hill, and Oscarthorpe, which is again an old quarry. The sort of current geological survey map, this is my interpretation of it, so it's you can blame me for the lurid colours. Basically, it's a junction between the Carboniferous rocks and the Triassic rocks. The Triassic rocks are the brown rocks, so they're the youngest, and the Snedden Formation above the Bronze-Grove Sandstone. I've been using the old terms rather than necessarily the ones that are currently used. Then you've got an area of millstone grit, in the middle of which is a Ticknall limestone. And then you come to the most significant structural feature here, which is the Princeton fault, which, as you can see, is a reverse fault. All the other faults noted here are normal faults. And that basically brings the other aspects of the Carboniferous rocks up against the younger rocks. If you look at it, it is in fact, has been described as an anticline. So looking across the area, we've got the Heath End Colliery, which was one of those that was mentioned earlier. And it's an anticline basically, where relative to our understanding at the moment, the pond is basically the laundry pool. There's no current exposures that I'm aware of the Carboniferous limestone. If there are any, then they're underwater. There are lots of lumps of it around, but nothing attached to the rest of the world. But the millstone grit's different. This is on the back of the area that presumably was part of the collapse, and it's the millstone grit. So if we move on to the minerals, there are 3 different minerals that we're talking about here. The yellow ones we'll see pictures of. Those in lowercase are relatively minor, and the ones in capitals are the major minerals that are present in the specimens that have been found either locally or in museums. And we'll go through those in alphabetical order. So we've got auricalcite. Technically, this was actually found in Derbyshire because it's from the edge of one of the Harpur-Crewe lime pits. But and the auricalcite is the greenish blobs. Field of view is not brilliant, but in terms of size, but they do stand out quite well against this browny background. Barite. This is the main matrix of what's being produced here in a geological sense. we'll see this specimen a number of times because it's quite impressive from the Sheffield City Museum. They've had it for a while, 1888, but and the barite looking at is this one. It's the surface expression of a barite lump underneath it that then goes into dolomite limestone. But it is characteristic of these little wafer thin leaflets, sort of all on edge, all over it. It's quite a common substrate for some of the other minerals. And you can still see calcite and galena on this one as well. Bitumen. There's a lot of bitumen here. It obviously, it's an acquired taste, but as an organic chemist, I think it's rather good. It is organic chemistry written in geology. So these are all hydrocarbons with various other side modifications. This one's in the museum here. This one's in Cork Abbey. And it's actually quite a big specimen, as you can see, 155 millimeters. And it has a single large blob of bitumen, which is about 10 millimeters across. And it's a rather nice specimen. The unfortunate thing is that it's suffering. As you can see, got a crack going across it. And there's pyrite in there, and it's almost certainly got the early stages of pyrite rot, which may or may not cause the National Trust a bit of a problem in the future. Neil and I are currently cataloguing the minerals at Cork Abbey for the National Trust, and there are some terrible minerals there in terms of their pyrite rot. They shouldn't really be in the collection at all. They should be somewhere else. Otherwise, they will infect the rest. One notable thing was that there are actually quite large masses of bitumen here, and this is one of Bob's specimens from the National Museum of Wales. And in his archives, there are descriptions of stalactites of bitumen actually when they were digging the mines out in 1939-42, that almost blocked the passages. And when there was access, the estate workers used to use the bitumen as firelighters. An apocryphal story, but calcite, that's one of them, as it is in many places, one of the more common minerals. Again, this is one from Sheffield City Museum. Another one from Sheffield City Museum shows these large scalenohedral calcites, some of them doubly terminated, but you'll notice that the ground mass here is also same calcite color, and it is actually an earlier generation of calcite. So there are two generations of calcite on this specimen, which is why it's in the talk. There's quite a lot of calcites in the Rashleigh collection. Quite a lot of them have this yellow cast to them, which is not uncommon for calcite, where they've got sulfides, particularly iron sulfides. And there's also galena associated with this. And one of Neil's specimens. And the image was taken by Nick Cooper. So again, lovely calcite, doubly terminated calcite crystals with some sphalerite in this case, and chalcopyrite. Moving on to chalcopyrite, one of the major minerals, it's usually present as these little bright golden yellow tetrahedrolite crystals. In this case with calcite, and on the right there's some sphalerite, but it doesn't show up very dark in this picture. Again, one from the National Trust. Some of the chalcopyrite crystals are quite large. See, the field of view here is 60 millimeters by 50 millimeters. So the crystal in the middle there is actually a decent sized one. But again, this one in particular is from the Rashleigh collection in the Royal Cornwall Museum. It says cinnabar on here, and we'll get to cinnabar in a moment, but I thought you might like to see the specimen that would be, this is why most people would have picked this specimen up. It's the traditional amount of sort of red barite, massive barite, dolomitized limestone, galena, calcite, and sphalerite. But the interesting thing was that Bob had received this specimen in exchange from Repton School. Whether he knew at the time, or he certainly found out later, that there was cinnabar on here. Now, the specimen itself is in the National Museum of Wales, but I've managed to borrow it for a bit, and you can just about see two reddish areas, one there and one there. And Bob says that there are two small areas of thin, vivid red. Well, it's reddish brown to me, but with sphalerite. Certainly, there's mostly sphalerite that you can see here. Varies from very dark yellowy brown through to quite a nice light yellow. That's the only specimen that anybody knows of that's got cinnabar from this particular locality. Galena, this was obviously the subject of the mine in terms of what it was actually being worked for, if it was being worked for anything. And we've seen it before. And these, you can see the crystals there are grey octahedron, and that they are rather rough looking because they've got lots of little crystallites on the surface. But they are basically cubo-octahedral galenas. One in the Ashley collection in the Royal Cornwall Museum. Again, in this case, just galena and calcite. And in fact, there's more calcite on the other side. There's some big bucks there for you, get a lot of bang for your bucks. Geological survey, Kiva. Again, galena and calcite.
Yeah, I'm fine, thanks. How's things going?
This would be a nice specimen, but in keeping with most of what goes on at the National Trust, you can't do anything with it. It's a really dirty, scruffy little thing, but it's interesting in the sense that it's actually got two generations of calcite, galena. You can see the octahedral crystals here, cubo-octahedral crystals, but there are some cubes here, which makes it quite an interesting specimen. I'm sure it would look quite nice if it was washed, but it hasn't been. This is a specimen that Bob King got from Arthur Russell. So this, again, collected or was first recorded in 1790. So it's quite an important specimen from that perspective. It's in the National Museum of Wales in Cardiff. Although it may be difficult to appreciate, this is actually galena as well. It's a reticulated form, lots of interlocking, more or less right-angled junctions of galena. And this was the one, or similar to this was one that Jacob Forster had in his list that we mentioned towards the start of the talk, of what they call knitted galena. So it's reticulated ex-galena. And again, this was taken from Nick Cooper's book, and it's one of the images that Roy Starkey took when he was photographing things for his minerals of the Midlands, which you probably know about. Electric calamine, this is what Salvi called, you've seen this specimen before. This is what Salvi called these yellow crystals that are shown, presumably life-size, underneath the specimen and then blown up on either side. And this was the one that was sent by Ferrers to Miss Codrington. It was analysed and shown to be a combination of calx of zinc with quartz. Now, specimens of that type since have been analysed as which, as you can see, zinc silicate. But unfortunately, hemimorphite usually crystallizes in this sort of shape. It's hemimorphic, hence the name. So opposite ends of the crystals are different habits. So it's angular at one end and chisel-like at the other. And it's obviously not particularly true of the specimens of the yellow crystals, which are being highlighted in Saudi. We'll come back to that in a moment. Marcasite, there was quite a lot of marcasite and pyrite, as we'll see in a moment. It's the ground mass here, and they're small tabular crystals of ferric iron sulfide, in this case with calcite. Quite a lot of pyrite. Some of it is in this sort of massive lumps, and it's got this sort of dusty finish to it, which is an early stage of pyrite rot. So beware any shiny ones that are now starting to go dull. And as Russell said to Bob King, specimens of pyrite or marcasite have gradually decomposed and split with nasty efflorescence, but this is the beginning of the efflorescence. And it smells a little bit. However, some specimens are quite stable. This is also what might best call a nodule almost of pyrite. Again, it's in the National Museum of Wales. But the photograph itself was taken by Bob in the 1970s for his PhD thesis. Sphalerite. This is how sphalerite usually occurs in the limestone in both Leicestershire and to some extent Derbyshire. These little black nodules, usually with barite and calcite, and in this case with a few of the sulfides as well. There are some really magnificent specimens. This is one. A photograph doesn't do it justice, but the gold-coloured chalcopyrite is really set off very nicely against the sort of slightly purply grey sphalerite. I was very pleased to see that in the Royal Cornwall Museum. Also sphalerite in the Sedgwick Museum at Cambridge University. Number shown there. I didn't realise the significance of this specimen, so it's not actually a very good photograph in my opinion, but or anybody else has come to that. So if we blow up the little bit that's there, if you, with an eye of faith, you can see that it's actually a prismatic crystal. He said, hopefully, and it's not alone. It looks a little bit like ones from Sowerby's drawing. Unfortunately, the whereabouts of this specimen are not known, so we haven't been able to find it and do any analyses on it, which is why I'm interested in finding Miss Codrington's family. Could it be yellow sphalerite? Well, the Cambridge University specimen is anything to go by, possibly. On the large specimen of that we saw earlier from the Sheffield City Museum, there's one little crystal which is highlighted there, which managed to get a slightly better photograph of. It's not particularly big, obviously, about 3 or 4 millimeters long, but it certainly looks a lot more like the crystals shown on Sowerby's diagram than hemimorphite. And on specimen that I've found since, you can see here they're very small crystals because it's a 4 by 4 millimeter photograph, but certainly there is a prismatic crystal sticking out there, and some of the others have not fared so well during the taking of the photograph. Which brings you to the point that that the crystals here are probably sphalerite, although it would be nice to have the original specimen to analyse. From a paragenesis point of view, Bob had this in his thesis. So you've got all the various minerals on the left-hand side, basically representing time going across the right. So earliest were the dolomite and barite, and then through the various ranges of sphalerite. Bob puts them quite early, but I'm a bit cautious about this because one or two of the specimens seem to have sphalerite over galena, but that's a technical point that remains to be seen. And then there are a load of supergene minerals where oxidation and various chemical processes have given rise to all the yellow-green minerals at the bottom, some of which we've seen and some of which we haven't. So lots of people have done lots of stuff here before I did. You can see all the people who supplied photographs and data. Yes, Mark was there, and Heather, who was the current person in charge, but it's not quite so easy to get in there as it was when Mark was there. Indeed, that's true of the geology department at the university in Cardiff as well, where currently they've lost all of their mineralogists and petrologists to a shake-up. Geological maps came mainly from BGS, and we've seen various other collections that I've investigated. And the man who started it all, as far as I'm concerned, a picture that's well known in Brussels Society circles of Leicester Mercury when there was a mineral show at the Holiday Inn in 1981. Okay, any questions?
Okay, thank you very much, Frank. So do we have any questions in the room? Yes, right at the back.
Yep.
Thank you. In terms of the wide significance of the site, things like preservation and geoconservation, I have read in a few papers on this site that certain assemblages of minerals that found combinations of them unique, in that they're not found anywhere else, and described anywhere else. I was just wondering, firstly, did you have any comment on that's true? Sorry,
Anyone?
any comment on whether that's true? And secondly, do you think that features perhaps like that in this site needs more looking after? I mean, I've been up there in August, and it's very overgrown. It's virtually impossible.
Yeah. Just for the people online, questions about the sort of geoconservation significance of the site. So over to you, Frank.
Yeah, there are certainly a number of things going on. There are other exposures of the Carboniferous limestone. We mentioned some from Charles Smith's map of Breedon Quarry and Cloud Hill Quarry, and they have a series of minerals which are not dissimilar to this, but not exactly the same. So there is a tie-up between those two. So I don't think it's obviously every site in a sense is unique, but it does have parallels with other parts of the Leicestershire Carboniferous rocks. Yeah. In terms of geoconservation, it's being taken quite seriously. There's obviously a move from the National Forest and various other organisations to make sure that geology is represented in various conservation ways. The National Trust take their responsibilities fairly seriously, which is why Neil and I help them to catalogue so they can see what they've actually got. Actually, in the house, they have been with us once or twice when we've been down there looking at various features, as are the Derbyshire Wildlife Trust. They're still involved as well. Derbyshire and Leicestershire.
Leicestershire.
Oh, Leicestershire. Yeah. Oh, yes. Yeah, sorry. So yes, I think its significance is known, but it's a question of how much effort goes into actually doing anything to maximise its interest to the general public. That would be nice. There are one or two boards up here and there, as you've probably seen, but as far as I'm concerned, there's not really very much to do with minerals there. It's largely to do with wildlife.
Do we have any other questions in the lecture room? Do we have any in the chat from online?
No, I can't find any.
Hello, can you hear me?
Oh yes, we can hear you, Roy.
I just wanted to ask, is there any evidence as to the nature of the genesis of the deposit?
Sorry, missed the crucial.
Any idea how the deposit was formed? What were the processes involved?
I think the assumption was that it was hydrothermal fluids in the way that it is in most of the Derbyshire ore field. They would have been squeezed out of the coal measures in the way that they are to some extent. Sulfide-rich brines would have been coming through the limestone and actually being deposited where they met different conditions. So it's in that sense, it seems to be similar. There's no work actually, as far as I'm aware, been done on the actual dating of, say, the sulfides or the any other of the minerals, but something that would be useful to be done in the past or done in the future. But that enough?
Yes, that's right.
Yeah.
Good. Thank you. Any other questions? Guess I've got one, perhaps more historical question, but
Yeah.
given the closeness of the site to Leicester, is there any evidence at all of any sort of Roman activity mining the lead, or would they not have been aware of it, do we think?
As far as I'm aware, no. The earlier records, I haven't specifically looked for any indication of Roman working, but the fact that it was being worked for iron, limestone and coal in the 1300s, which was basically along with lots of other areas, seems to be the first time that it was actually being mined. And then, as I say, it was the mid-1770s before it actually was noted, first of all. But I don't think there, I mean, based on what we can see, there wouldn't have been very much lead actually generated from these mines. Their interest is largely in the specimens that are spread around Europe and also in the USA.
Okay, thanks. Any other questions? In which case, I'd like to thank Frank again. If you'd like to join me, we can. So our next meeting is 27th, and it's entirely online. Is that right? Okay, in that case, we shall see you virtually in 2 weeks' time. Thank you, everybody.